This video is an introduction to writing design reports. It corresponds to sections 7.1 and 7.2 of the Applied Analog Electronics textbook. Now, the basic idea of writing in this course is that you're going to be writing design reports. These are not like high school lab reports where you were just showing that you'd successfully followed some sort of cookbook procedure. These are an explanation to engineering managers and to future engineers about how you designed the particular design, what design decisions you had to make, why you made them the way you did, and in many cases, providing enough explanation that the future engineers can change the design and can look at, oh, they made the decision that way, but things have changed, that's not what we want anymore. How do we make it different now? And not have to redesign the whole thing from scratch, but can just understand how you made the design you did and make the improvements. Each of your reports should be well written. It should go through multiple drafts. It should not be, oh, here's my first attempt, I just gave you my notes. That's not what an engineering design report is. A lot of people go into engineering because they think, oh, I don't like to write, so I'll be an engineer. I just design things and not have to write anything. Bad mistake. Engineers probably do more writing than most other professions. Now, the writing is a very particular type. And the important things in engineering writing is that you be very clear, that your reader really understands what it is you're trying to say, but that you also be correct. You don't simplify things and make mistakes just to say, well, that's good enough. Engineering writing has to be very precise, very correct, but also clear. Those are kind of in tension with each other. It's hard to be both correct and clear. It's a lot easier to be sort of hand-wavy and but that doesn't help in an engineering writing. You also have two other things in tension. You need to be complete. You need to explain everything in the design. Things that you left out are unexplained. People need to know that detail, and the detail's not there, they're screwed. They have to go and reverse engineer, undo what you've done, try and figure out how you got there. So completeness is very important. But on the other hand, they have to be concise. Nobody wants to go through an 800-page document in order to find out that one little fact that's on page 732. So you need to be concise to keep your writing as short as you can make it without leaving things out. So being complete and being concise are in tension with each other. Being clear and being correct are in tension with each other. This makes engineering writing difficult. So I'm not going to pretend to you that the writing you'll do in this course is easy. In fact, it's some of the hardest writing you will do until you get out into the real world and have to write engineering design reports for real. But it's also very important because writing is, in fact, the main product for most engineers. This is what you turn in when you're a consultant or when you're a designer. Here is my design. It's a report. It's not just a piece of hardware. A piece of hardware without documentation, pretty much useless. So think a lot about how you're going to do your writing. Start your writing as soon as you start your design. You start drawing a schematic. Explain what's going on in that. You make a decision about how big a resistor is. How'd you make that decision? Write it down. Don't say, oh, I'll write it down later, because later on you may forget, or you may go, oh, was that 10 kiloohms or 2 kiloohms? I don't remember now. Write things down as you go. Write down the explanation of things as you go. And then later on when you're trying to debug, you go, oh, I thought it would do this, but oh, that's not right. It's not doing that. Is it the hardware that's wrong? Is it my design that's wrong? If you don't have the stuff written down, it's very hard sometimes to pin down oh, I just waved my hands at that. I sort of knew what I was doing, kinda. Doesn't help. Being in writing helps a lot in debugging your designs. So don't leave your writing to the end. Do your writing before you start building your hardware. And then if you find things didn't work in your hardware, that you had some ideas that were wrong, then rewrite, edit your writing. Try to make things as clear as possible. Having a partner helps a lot with this because you're going to be explaining things to your partner by writing them down. Okay, but who are you writing for when you're writing these design reports? Now, a real design report, one that you do in the real world, would be to an engineering manager or future engineer, as I said before. And that's a good audience to think in terms of, is people who will need to understand your design in detail. Now, a lot of you are used to writing for the instructor of your course. That's an impossible audience to write for, because you're assuming, oh, they already know all this, and so you've got nothing to say. And we've got nothing to say, it's really hard to write. So don't write for the professor. That's just, you're setting yourself up to fail. Write for somebody who wants to know the material and doesn't already know it. But you don't want to write a textbook either. Believe me, writing a textbook's no fun. So you have to figure out, well, what do I leave out? There's this completeness versus conciseness. If you try to include everything they might need to know, you end up writing a textbook and it's not concise. So completeness depends on who's your audience. What do they need to know? What's new information to them? And that's what you need to include. So one of the easiest audiences to write for are people like yourself who are just a little bit behind. So where were you before you started doing this assignment? Before you started doing this lab, what do you already know? Your audience probably knows that. But the stuff that you had to do specifically for this thing, for this design, they don't know that yet. So that's what you have to explain. What's new? If it was new to you, it'll be new to them. So writing for people like yourself, but just a little bit behind, writing for next year's class, something like that, works really well for getting the right level of completeness and conciseness, the right level of clarity. So think about your audience quite a bit. That's one of the first things that every writing class always tells you is determine your audience, write for your audience. When you're writing for these lab reports, assume that your readers have no access to the textbook, no access to any pre-labs or homeworks that you did. Everything they need is in this report. It's the only piece of documentation they've got. Now, general background knowledge, what's a resistor, what's a capacitor, those things you don't have to explain, but the things that are, okay, I'm trying to design something that does this. Well, what is it you're trying to design? Don't assume that they say, oh, well, everybody knows that I'm trying to design a pulse monitor. Because your reader doesn't know that. Your reader has not read the assignment. You have to tell them, what is it you're trying to do? How did you do it? What does the final product look like? What does the design come out being? What design decisions did you make? And what's your justification for those decisions? So the reasoning behind your design choices is just as important as the choices themselves. So if you said, okay, I made a choice to make this filter have this cutoff frequency, or I made this amplifier have this gain. That's not enough just to say the gain is 100. Okay, so the gain's 100. Why? What made you choose 100 and not 50 or 200 or 3? It's these reasoning behind the choices is what makes this thing into an engineering design report and not just a technician's description of, oh, I read this circuit and there's this, and this in it. I don't know why they did it that way. It's just the way it is. You want to be explaining why things are the way they are, so that if somebody wants to change and say, we've got a slightly different problem here. Our sensor's now changed its output. It's no longer putting out this sensitivity. It's got twice the sensitivity it used to have. What do we need to change? Those sorts of, what do we need to change if something changes on us? Components change, things go out of manufacturing and have to be replaced by something that's not quite equivalent. Those sorts of changes, the engineers need to understand your design decisions, because it might be, oh, well, we were taking advantage of the special property here. That special property is no longer there. They have to redesign around it. But if you don't tell them that, oh, we were taking advantage of this special property, they don't know it. They try to plug it in, it doesn't work, and oh, great, it doesn't work. Now what? So explain your decisions. Okay, that's basically the main things about audience and the overall, what is a design report about. Pay attention to that. Write for engineering students, because that's the easiest audience for you to write for. Later on, when you're a working engineer, you'll be writing to fellow engineers and engineering managers. So think about what they need to know. What don't they know already that you can tell them that's specific to this design you're doing? Explain your decisions. Don't just give results. It's not about getting the answer. This is not an answer-getting class. There are many, many different correct answers. There's many better and worse designs. So explain why you chose the particular design you did. Make it clear that there was reasoning behind it, that it wasn't just, oh, I saw it on the web, so it must be this way. Explain what you're doing. That's the important thing in a design report. And get everything correct. Don't have, oh, it's 2 ohms here, it's 20 ohms here, 200 kilo ohms here. If it's not consistent, it can't possibly be correct. So correctness is really important. In fact, quite often I will fail an assignment, make students redo it completely if value on a schematic is incorrect. Because if the schematic is incorrect, the report is just wrong. There's no question. It's not, oh, it's almost right. If it's wrong, if you build the thing and it doesn't work, it's wrong. Redo it. And so one of the also very important things about having a partner and doing this stuff, check each other's work. Never trust your partner. Never trust yourself either. Make sure your partner checks everything you did. Make sure you check everything your partner did, because you'll make little mistakes. You're human beings. Human beings make mistakes. You'll find mistakes in my book. Incidentally, if you find any mistakes in my books, send them to me. I have a 25-cent reward for first report of any error found in the book. I know there are mistakes in there. I can't see them all myself. So if you find them, let me know. Same thing with your partner. You're each going to make mistakes. Try to find them. Try to fix them. Okay, that's enough general stuff. I will talk more detail about writing reports in subsequent videos.